Welcome back, everyone. It's time for another one of our videos. Right now, I'm using my tripod as a selfie stick, so somebody please help me. I think I've gone a little crazy. But we've got another lab for you guys to do today. This one actually is kind of cool. There's a lot of context to it, which I'm going to give to you on our Google Classroom because I don't really want to explain it all here and then also have you read it. It doesn't make that much sense. So I'm just going to show you what's going on. Hopefully by now you've already looked at the Google Classroom. You've already got to know what's going on. But selfie stick, weird. I know, I got it, right? Also, see the dog in the background? Skeletons. It's biology room. All right, so here's what we do. Here's what we've got this time. And it is this, which is going to be a camera to help give us another view. And we've got a hot plate with some water. And I should probably turn that on. I need that to actually get warm. So with that going on, the other thing that we have is I've got two of these. And what they are is it's water with green food coloring and a stop with a hole in it. And the hole has this tube, and the tube is a tube. It's not just a glass. Maybe I could turn it like that. You can see the hole in the top. And what that does is that allows for pressure to go in and out and do all of its thing. And well, it just gives us a vent. But because the tube is down inside the liquid there being water and food coloring, and if you're thinking, hey, is that the same water and food coloring as in the other demo? No, it's not. It's different. How do I know it's different? This is darker, duh. So anyway, so now we've got this, and then, well, I've got two of these. What I'm gonna do is I'm gonna take these two, I'm gonna put them side by side, and I'm gonna heat one of them, and I'm not going to heat the other one. The one that I don't heat is called a control. It shows you that, well, what happens if you take out the variable? The variable is going to be the heat. And we're going to see what happens. Which means I have to put down my selfie stick tripod and actually let the lab do its thing. So, fun. Look at this. As I put this directly in like that, and I'm going to swing this around so you guys can see it. And then I'm going to start the other camera because I want to have both of them. And I'm going to take my second one and I'm going to put it here in frame so you can see both. And if I do this right, I can make it so you can see both on both cameras because, you know, that might be useful. And now, well, now we wait. We can wait, right? We're okay with that? Okay with waiting? I hope so. Because we're going to have to wait. You know what we could do? Let's use a time lapse. Sound like a good idea? I think it's a good idea. Let's do that. Stop the time lapse. I forgot something. We need two more things. The first one is this. It's a ruler. Now, if I take this and I go like this, I can measure how high up into the glass rod the green fluid is. And on this one, it is at 6 millimeters. So, and on this one, even though it's already started warming a little bit, it's at 4 centimeters. Why is that one less? Because of the way it was put in there, it just wasn't up to the top yet. So, but now it's there and it's doing its thing. So we can go ahead and continue with the time lapse, but that's only one of the things that we needed. If we're actually going to do this and take data, well, what do we need? We need both variables, not just how high it is, but also what temperature. So I'm gonna start the time lapse back, but I'm also gonna go get a thermometer. All right, and so with that, we need to take and stop the time lapse because there's something going on here which is not gonna help us. We have reached the top of our thing. If I heat this up anymore, it's gonna start spilling at the top. And that's not good. So this has gone up from the very bottom all the way up to the very top. It's still rising. I can actually see it rising. We're at 11 centimeters, and I got to get this out of the water real quick, like, because I don't want to make a mess. There, out of the heat, doing its thing. I'm going to set it here next to this one. This one actually went up a little bit too. It went from 6 millimeters to 8 millimeters. That's just because of the proximity to the heat here. Let me move this, get it out of the way. What are we noticing already? It's already kind of starting to come down, isn't it? Because I've gotten it out of the hot water. So now, while you guys are watching that, I'm gonna fill up our beaker with cold water. So it was 55 degrees Celsius when I took it off. I've turned the burner off, but the burner is still already hot. I mean hot plate, not burner. And the thermometer is reading 24 degrees. If I take this and I put this in here, what do we expect to happen? Let's watch. Let's see. When I took it out of the hot, it was at 11. When I put it into the cold, it was at around 9. It's already, a few seconds later, already dropped past 8, approaching 7.5. It's dropping really quickly, isn't it? It is. Trust me. In fact, if we were to cool the green liquid in the bottom back to room temperature where it started, it'll go back to where it was. I think that's actually pretty cool. But there's a point for this. You guys have seen thermal expansion. We did that before. This is thermal expansion of a liquid instead of a gas. I think we've also done a solid. Oh yeah, we did solid, the ball and ring video. So we've done thermal expansion of a gas. We've done thermal expansion of a solid. Now we've done thermal expansion of a liquid. Guess what? Everything expands when you heat it. But there's more to this than that. Because this has the potential to change our lives, and not for the better. It's one of the major problems that we face in terms of global climate going forward. But hopefully you read the background information I provided you. Because if you didn't, then what I just said made no sense. And if you did, then you were already expecting this answer. And with that, you guys have work to do. Good luck. The power of science.